Hello IP students, today our topic is Python NumPy array. It is Python NumPy array part 6. In this lecture we are going to discuss about two functions related to Python NumPy array, and these are concatenate and split function. So first thing arises in our mind that what is concatenation? Concatenation is a process of joining of two arrays of same type, so and along the specified axis. As far as its syntax is concerned, first of all write the library name which it belong, and the library name is numpy. After that, function name which is concatenate, but before this dot sign should be there, so library name dot and then function name. And then after, you can pass arrays as a argument, more than one arrays which you want to be concatenate, and in this case a1 and a2 are arrays of same type. And then after axis means along row or along column, so both options are there. By default, if axis is not mentioned, by default axis is 0, it means row wise. So that is the syntax of Python NumPy array concatenation. Here is an example. Actually it is a program. So first line is import numpy as np. Import is a keyword, numpy is a name of library used to numerical calculation, and all array calculations belongs to this library. So just use numpy, then keyword as, and then np. Basically np is a alternative name of numpy. And in next line, a is equal to np is equal to array 1 2 3 4. Array function is used, and an array is declared using array functions. In third line, there is a message, first array will be printed, and then print a. It means this statement basically print the array which we formed in line number 2, and then print /n means next line. So execution of the statement or cursor basically goes to next line. And then b, here there is another array declared using array function, and element of these array are 5 6 and 7 8. After that, a message will be printed, second array, and then print b means that array which we declared in line number 6 will be printed. After the /n means go to next line, and then there is a comment. And after that, if you want to join these arrays, just write a statement using print statement joining the two arrays along x-axis. So print np dot concatenate. Concatenate is a function to join two arrays along axis 0, and these arrays are a and b, which are declared in our statement, in statement number 2 and 6. So axis is not mentioned, and by default axis is 0. So these two array will be concatenate along axis 0, and after that there is a statement again joining the two arrays along axis 1, and then there is a print statement, np dot concatenate is equal to ab comma x is equal to 1. So array will be concatenate again, but along axis 1, means column wise. So there is basically a program which concatenate two arrays along axis 0 and along axis 1. Let us check its output. What is the output after execution of that program? This is the output. This is array 1 1 2 3 4, then second array, and then joining the two array along x-axis. So along x-axis it means along axis 0 1 2 3 4 5 6 7 8, and along axis 1 elements are 1 2 5 6, and in next row 3 4 7 8. So there is a program to concatenate of two array along x-axis and along axis 0 and along axis 1. Axis 0 means row wise, and axis 1 means column wise. This is a pictorial representation of concatenation of two arrays. Array 1 have elements 1 0 1 3 5 7 9. Array 2 have elements 0 2 4 6 8 10. And here, when we use the function np.concatenate a and a is the first array, b is second array, and then comma 1 means along axis 1. Then after the execution of that statement, we got the desired result. It means concatenation along axis 1, and its element are 0 1 3 0 2 4 5 7 9 6 8 10. So this is a pictorial representation of concatenation of two array along axis 1. Now there is another example which demonstrates the concatenation of two arrays along axis 1. So first of all, just write import numpy as np. This line is very essential because if we want to use any array function, we have to import library numpy. And then a is equal to np.array 013579. So array is a function, belongs to library numpy, and we give a alternative name np. So just use np.array. So there is a declaration of an array named a, and then in second line there is another array named b, and in next line there is an array c, which is a result of concatenation of above two array, means a and b, but along axis 1, because in this line c is equal to np dot concatenate a b comma 1 is mentioned. And then after print c, so after concatenation statement will be printed, and then desired output looks like this: 0 1 3 0 2 4 row 1, and row 2 5 7 9 6 8 10. Now there are some more example. Next function is numpy stack. Stack is also used for concatenation, and it is quite similar to concatenate function, but its syntax is little bit different as comparison to concatenation. Let us check it with an example. First of all, just write import numpy as np, and then np array 1 3 1 2 3 4. So there is an array declaration, and line number 2 3 4 and 5, 2 3 4 will basically print the statement, print the array. And then line number 6, b is equal to array np dot array 5 6 7 8. So there is a declaration of another array, and then this array will be printed. And after that, horizontal stacking. Basically, as stacking refers to horizontal stacking. So horizontally concatenation, we can also say that these are other functions used to concatenate of two arrays. Just write library name. In this case, library is numpy, and the alternative name of numpy is np, so we just use np. Then after dot sign, and then stack, and after that ab will pass as argument, and then print c. So there is a statement which print the desired result. After that, print /n means next line. Let us check what happens using stack. So this is the example of numpy stack. First array will be printed 1 2 3 4, second array will be printed 5 6 7 8, and this is horizontal stacking. It means concatenation. So 1 2 5 6 and 3 4 7 8. So it basically concatenate along axis 1. So if you want to concatenate um, without using concatenate function along axis 1, you can use stack function. So this is the use of stack function. Using stack function, it is not possible to join two array along axis 0. Next is VStack. VStack is just opposite to that of HStack. It means vertical stack. It means joining or concatenation of two arrays along axis 0. So there is an example again. Import numpy is np. A is an array. Next B is declared as an array, and then after, let us check directly last line. C is equal to np dot vstack ab, second last line, in which concatenation of two arrays is there using vstack function, and then after only print statement will be there. After execution of that program, that result is looks like this. First array is 1 2 3 4, second array is 5 6 7 8, and after execution of that program or execution of concatenation, vertical stacking looks like this: 1 2 3 4 5 6 and 7 8. So this is vertical stack. So this is all about concatenation of two arrays. Next topic is split function. So a split is again of three types: horizontal split, vertical split, and split function. So if you want to split two arrays along horizontal, then we can use directly h split function, and along vertical axis we just use v split function. But if you want to mention axis, then a split function can be used. So split, basically we can say that is a combination of h split as well as v split functions, and using these functions we can split one dimensional and two dimensional array both. Let us check one by one. So numpy h split is a special case of a split function where x is 1, indicating a horizontal split regardless of the dimension of the input array. As I told you earlier, that it is a special case of a split function. In a split function, basically there is a split of an array along axis 0 and axis 1, and it is we can say that it is a combination of horizontal split and vertical split. So h split and v split are two functions used to split an array along axis 0 and axis 1, and a split function is a combination of both these functions. So there is a diagrammatically representation, pictorial representation of h split function. Its element are 0 2 4 1 3 5. After writing np dot h split 2, it divide it into two different parts. So let us check. Let us do another example, another program. Import numpy as np. Again, import is a name of import is a keyword, numpy is a library, as is again a keyword, np is the alternative name of library numpy. Whenever we want to use numpy, just write np there, and if you want to use any function regarding to that library, just write library name, then after dot sign, and then after function name, just like used in line number 2. So a is equal to np dot arrange 16 dot reshape 4 comma 4. So basically these function arrange and reshape are um, used to declare two-dimensional array. So arrange function create a one-dimensional array and its element starts from 0 to 15. Last element is 15, and total there are 16 elements. So there, then reshape function again reshape it into 4 into 4 array. So this is done by line number 2. Then print first array. First array is array A, and actually there is only one array A, and second array is second array we got after splitting that array. So line number 5, there is a message horizontal splitting. Line number 6, at p dot h split a2. So it's so this line basically divide array A into two parts, and after that there is a print statement regarding to that array B, and after that print slash n. It means cursor goes to next line. Let us check what is the output of that program after execution. The first array is looks like this: 0 1 2 3 4 5 6 7 8 9 10 11, and last row contain element 12 13 14 and 15. So we divide it into two parts. So after splitting, horizontal splitting, we get array 0 1 4 5 6 9 12 13, and second array contain element 2 3 6 7 10 11 and 14 15. So horizontal split is there. Next, vertical split, it is just opposite to that of horizontal split. Rest things are same as that of horizontal split, and the pictorial representation give the clear idea about vertical split. And it split here an array into three different parts because we pass 3 as the argument in vsplit function. So what is numpy vsplit? So numpy vsplit is a special case of a split function. Again, it is a special case of split function because using split function we can split split an array into two or more different parts along axis 0 along axis 1. But using split function, we split a function along horizontal axis, and using v split along vertical axis. So numpy v split is a special case of a split function where axis is 1 indicating a vertical split regardless of the dimension of the input array. So there is an example again. It is actually it is similar to as that of previous one, but the only difference is that instead of h split, v split function is used, and the rest everything is same as that of previous one. So second last line is b is equal to np dot v split a into 2, that line. So here only v split function is used, rest things are same as that of previous one. So actually vertical split will be there after execution of that program. Let us check what is the output of the program. So this is the output of the following program. After execution we got first array, and then after vertical split array will be 0 1 2 3 4 5 6 7, and second array contain elements. First row have elements 8 9, first row elements of first row are 8 9 10 11, and second row are 12 12 13 14 and 15. So this is the use of v split function. Now a split function, as I told you earlier, that split is nothing but only the combination of v split and ANSI split functions. So let us check what is the syntax of split, numpy split. This function divides the array into sub arrays along a specified axis. So basically axis uh, will be specified only then there is a split, otherwise there is no split if axis is not specified. Actually by default axis is 0, so but it perform basically horizontal and vertical type of splits, or it is a combination of h split as well as of v split. It is a combination of h split and v split both. So this function divides the array into sub array along a specified axis. This function takes three parameters. Now this is very important point. This function takes three parameters or three arguments. So syntax is numpy 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 is the name of library, then split function, then name of array, and then indices of section access. So there is a description of these parameters. First of all, ARY. So ARY is the input array to be split. ARY is the array which you want to split, and then indices or sections. Actually, if you want to divide or split into more than two parts, it is possible using indices parameter. So it can be integer, and indices indicating that the number of equal sized subarray to be created from the input array. If this parameter is a one-dimensional array, the entire indicates the point at which a new subarray is to be created. And axis by default is 0. So this is the syntax of numpy split. Let us check it using an example. There is a pictorial representation of numpy split. There is a one-dimensional array 0 1 2 3 4 5, and we use here function split and p split 2. So as I told you that by default axis is 0. So after a split function we got two arrays which contain elements 0 1 2 and 3 4 5. But if we just write x comma 2 6, so x is the name of array defined and its element are 1 2 3 4 5 6 7, array number 2. This is array, this is an array number 2, 1 2 3 4 5 6 7 8 9, and here we mention 2 comma 6, 2 comma 6, and we split x 2 comma 6. So it is basically index value, two index value is given 2 comma 6. So what will happen? So after passing that argument, actually what happens, first array or first split array contain only two elements. It means from index value 0 to 2, which is mentioned, because which is mentioned here 2 comma 6. So first is 0 to 2, second is 3 to 6, and after that 6 onwards up to last elements. So there are three elements we find here. This is one first, this is two, and this is third. This contain element from index value 0 to 2. This contain element from 3 to 6, and this contain element 7 and last means up to end. So in this way, if different index value will pass as the argument and separated by a comma, then array will be divided into unequal parts as mentioned in this example. Next, there is a program import numpy as np in first line, then in second line np arrange. So one dimensional array is declared in this sentence, then print a, then slash n. Next line, print a means one dimensional array will be printed after execution of that statement. Then print statement, and here we mention a comma 3. So in this program or in this line, b is equal to np s split a into 3, so divided into three parts, three equal parts. And then here a comma 4 comma 7, it means three parts will be there from 0 to 4, from 5 to 7, and from 8 onwards, means 8 up to end. Let us check its output. First array is 0 1 2 3 4 5 6 7 8, three equal size, as I told earlier that since there is split a into a comma 3, so divided it into three equal parts. So first array is 0 1 2, second array contain element 3 4 5, and third array contain element 6 7 8. And in this line, np split a comma 4 comma 7, so three array, we got three arrays starting from index value 0 to 3, 0 0 1 2 3, and then up to 4 to 7 index position, and then onwards. This is an array, and since this function contain split a comma 4 comma 7, so first 4 comma 7 means first 4 index will be there, and these are 0 1 2 3, 0 1 2 3 index value, and at 4 index value, fifth index value element is element is 4, so 4 5 6 will be there, and 4 5 6, and after that 7 and 8, 7 and 8. So this is very important. A 4 comma 7 means first four elements. First array, first split array contain 4 elements from index position 0 to 0 to 3, and then 4 to 7, and then after 7 onwards, 4 to 6, and then 7 onwards, sorry, 4 to 6 and then 7 onwards. So I think now it is very clear to all of you. In next lecture we solved some numerical regarding split functions, basically regarding two-dimensional split functions, and I hope you like this video. Thank you very much.